How to calculate shear stress. If you're curious about how to calculate shear stress, you're in the right place. Shear stress is a fundamental concept in physics and engineering, and understanding how to calculate it can be really useful. Imagine you're trying to cut a piece of paper with scissors. The force you apply to the scissors creates a stress on the paper, causing it to tear. This is essentially what shear stress is, a force that acts parallel to the surface of an object, causing it to deform or break. To calculate shear stress, you need to know two main things: the force applied and the area over which this force is applied. The formula is simple. Shear stress, tau, equals the force F divided by the area A. So, tau is equal to F/A. Let's break this down. The force F is the amount of push or pull applied to the object. This is measured in Newton's N. The area, A, is the cross-sectional area of the object where the force is applied, measured in square meters, m squared. For example, if you have a beam and you apply a force of 100 N to it, and the cross-sectional area of the beam is 0.1 m squared, the shear stress would be 100 N/0.1 m squared is equal to 1000 Nm squared, or 1000 pascals. Now, this formula works for many types of materials and situations. However, there are some special cases. For instance, when dealing with fluids, the shear stress is calculated differently. It involves the viscosity of the fluid, mu, the velocity of the fluid, u, and the height above the boundary, y. The formula here is tau is equal to mu, u/y. In engineering, especially when dealing with beams, there's another formula known as the Jarovsky formula. This is used to calculate the shear stress in beams and involves the total shear force, V, the statical moment of area, Q, the thickness of the material, T, and the moment of inertia, I, of the entire cross-sectional area. For impact situations, like when a solid round bar is subject to an impact, the maximum shear stress is calculated using the change in kinetic energy, U, the shear modulus, G, and the volume of the bar, V. The formula here is tau is equal to 2 Ug/V, 1/2. So, whether you're dealing with a simple force on a solid object or complex fluid dynamics, calculating shear stress is all about understanding the forces and areas involved. By using these formulas, you can determine the shear stress in various scenarios, helping you design and build safer, more durable structures.